Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so in this session, we are going to continue stiffness method. So this is beam analysis. Okay, stiffness method, as we know, this is another method to analyze indeterminate structures. Okay, we start stiffness method with truss analysis, where truss has 2 degree of freedom. Okay, the degree of freedom in X and Y component, degree of freedom, and in beam, number 2 is beam. Okay, and beam has also 2 degree of freedom, but in Y and Z component. Okay, and we have another one, frame, frame. Here we have 3 degree of freedom in X, Y, and Z component. So all these are the degree of freedom, and this degree of freedom we apply at each node. Okay, so basically for the procedure will be the same. Okay, except in truss and frame, we have to have coordinate. We have to put coordinate, because from the formula we have to calculate Cx and Cy. From the formula we have to calculate Cx and Cy. So we have to calculate, we have to put coordinate. But for beam, we don't have to do that. We don't have to do that because in beam, the system, okay, it has the same local and global coordinate system. Okay, actually, this note is all example. Actually, it is a comprehensive example, and kalau you just study based on this pun, I believe you can follow. Okay, so kita go very fast before we do one example. Okay, taken from past year's exam papers. Okay, so example number 1 here. Consider the beam in the figure below. The beam is a continuous beam. With 3 support. Okay, joint A, B, and C. EI constant, calculate rotation at B and C. EI constant, calculate rotation at B and C. So what does it mean? Okay, we have to understand that. Okay, we have to be able to see the label, the numbering label for D1, D2, and so on, Q1, Q2 until the last Q, right, Qn. So we have to be able to relate with rotation, to relate with displacement, to relate with moment. Kita kena boleh relate yang tu. And then draw bending moment diagram for the beam. Okay, what rotation at B and C, what does it mean? Rotation at B and C. So this beam, if we look at this beam conventionally, the deflection of this of the beam due to loading and based on support condition, we have something like this. Displacement. It is something like this. Okay, displacement. Okay, this is deflection, beam deflection due to this loading, beam deflection. Okay, so from this we know that there is no deflection at B, because dekat beam ni ada roller. Sini ada roller. C as well, delta at C is equal to 0. And at A, we have delta at A, which is equal to 0. And why we draw the curve not start at A? Because of the support. So at support, at fixed support, dia punya theta at A is equal to 0. But what happened at B? Theta at B and theta at C, we can see the curve. So if we draw the tangent line for the curve, okay, the tangent line for the curve, okay, it should be same lah. Yang ni actually patutnya sama size dua-dua ni. Patut je sama je size. Okay, so this will represent theta at C, and this is theta at B. This is also theta at B. So that is why the question, okay, the question asks us to calculate rotation at B and C. So we have to be able to see rotation at B and C in numbering. So numbering ni we get from degree of freedom. Numbering we get from degree of freedom. So degree of freedom for beam, okay, we have A, B, and C. 3 nodes. Means that we have to have 6 degree of freedom. We have to have 6 degree of freedom. So from the diagram, we know that at A we have 2 DOF for constraint. 2 DOF for constraint. 2 DOF for constraint, and this is for 2 DOF for constraint. So how should we write? Okay, like this. Conventionally, bila kita dapat beam like this, what we do? What we do is we will draw the free body diagram like this. Okay, the free body diagram, we draw the reaction at the support and we label as AY, AX, MA, BY, and CY. So we will count the reaction at the support as 5, because we include AX at fixed. We include AX at fixed. But for beam, in stiffness method, we don't have to count X component. We don't have to count X component. So what we get is 2 at fixed, 1 at a roller. So we get 4 unknown reaction. We get 4. What we get is, okay, from 6 ni, we divide into 2. We get 4 unknown reaction. 4 unknown reaction. So we have another 2 unknown displacement. So total will be 6. Total will be 6. Okay. So we have to draw. So these are unknown displacement located in unconstrained system. Unconstrained system. And this is located in constrained system. Constrained system. So it's good if we have two beam like this. One for unconstrained, one for constrained. So another one for constraint. Okay, so there are four DOF in constraint system. There are 4 degree of freedom in constraint system, 4 degree of freedom in constraint system. Okay, there are 2 at A, 1 at B, and another 1 at C. 4. Representing unknown reaction. Representing unknown reaction. At A, we don't count 3 because we don't have to consider X component in beam. Okay, in beam. So we have 2 only. So it is 2, 1, 1. Total, there are 4 unknown reaction in constraint system. And we have 2 degree of freedom in unconstrained system representing unknown displacement. Du, U is for unknown, D is for displacement. So 2 du means 2 unknown displacement. Located in unconstrained system, what does it mean? We have to complete the degree of freedom, the 6 degree of freedom label in the diagram. We have to make sure that each node has 2 DOF. So at A, At A, no need to put anything. At B, we have to put another one, which is in Z component. And at C, we have to put another one, also in Z component. Okay. And after that, we have to label, and label must be started from unconstrained. Label must be started from unconstrained. So we can label as this: 1, 2, 3, 4, 5, and 6. We can label in anyone that we want to start. We can also choose this as 1, 2 if we want, doesn't matter. Okay, so from this, how we label 1, 2. Okay, it's up to you which one you want to choose as 1 or 2. Okay, so based on the example that I have, the solution that I have prepared, this is 1, this is 2. Okay, same goes to constraint system. If you want to start like this, 3, 4, 5, 6 also doesn't matter. 5, 6. It's up to you. Okay, it's up to you. Okay, but we take to example given. This is 3, 4. Okay, 3, 4, 5, 6. Okay, yang mana ada complete Y dengan Z, letak Y dululah. So, jadi 3, 4. Okay, 3, 4. Because we in element, nanti bila kita nak label the stiffness matrix tu, kita kena sebut YZ, YZ kan. Sama macam kita sebut for truss, kita sebut XY, XY. XY, XY. Bila kita label degree of freedom. Okay, so this is the label for degree of freedom. We have divide into two system, unconstrained and constrained system. So how to get this? How to get this? Kalau tak boleh nampak directly, so please draw dulu conventionally. Draw conventionally. Draw reaction at the support. Macam biasa kita draw before this. Cuma you don't have to count X component. So that is why dekat fixed we just have to count 2 degree of freedom. Okay, 1 and 1 at B and C. So there are 4 unknown reaction. 4 unknown reaction located in constraint system. 4 unknown reaction located in constraint system. So remaining we have 2. So these two belong to unknown displacement, which is located in unconstrained system. So this 2 and 4 kita transform dia jadi diagram. So we draw it separately so that we can be able to see clearly. Okay, unconstrained and constrained. And whenever we label, we have to label unconstrained dulu. Unconstrained dulu because we will get unknown displacement dulu, baru dapat unknown reaction. Okay, so we label 1, 2 in unconstrained system sebab we follow this. Okay, unconstrained, two unknown displacement located in unconstrained system, and 4 unknown reaction located in constrained system. So the label is like this. The label is like this. Okay, and in beam, since we have same local and global coordinate system, actually the arrow we don't need to put also okay, because understood the arrow is always going to the right direction, and we don't need that as well, and we don't need to have coordinate. We don't need to put coordinate as well. Okay, we need arrow when we want to have CS and CY. Okay, so sama macam tadi lah, labeling only. Okay, the next step. The next step is element global stiffness matrices. Element global stiffness matrices. Element, this is for element. K for element. K for element, we use small letter. K for element, we use small letter. Okay, global referred to the coordinate system that we use, global coordinate system, because we have two, local and global. And for beam actually we have same. So you can refer to the appendix. Beam has same local and global coordinate system. Okay, so and this is the formula given in appendix, and you don't have to write the formula. You don't have to write the formula. Just give me this only. Okay, you don't have to write the formula. So just just calculate the value, and put the value into the matrix. Okay, so in order to calculate K1, we just need to have L, because EI we have to make it constant first. Okay, so we calculate based on L only, based on length of each element. But what most important is how we label the degree of freedom in K, in K1, K2, K3. There are three elements. K1, K2, two element only. Okay, we have to be able to label it correctly, and we have to label start from near followed by far. Near completekan near, near X, near YZ, far YZ. Near YZ, far YZ. So if we refer back to the diagram, okay. Okay, this will always be the near end. This is far end for element number 1. So we have to label K1 as 3451. 3451. YZ, YZ. YZ, YZ. We must label correctly. We must label correctly. YZ, YZ. Start from near. It is 3451. 3451. So we repeat the same process for element number 2. Length for element number 2. We put into the formula, and then okay, and then the label for element number 2 will be 51. This will become near, this will become far. Okay, the label for K2 will be 5162. 5162. Okay, this one 5162. It is 5162. You must label it correctly, because if you don't label this correctly, you will get the wrong structure stiffness matrix. Okay, so since this beam has only 2 elements, so we have to combine K1 plus K2, so we will get this. Okay, we will get this. Okay, so K, we will have 6 by 6 because it will be depending on total degree of freedom for the beam based on how many nodes. There are 3 nodes times 2, 3 times 2 equivalent to 6. So we get 6 by 6, right? Okay, so K, the structure stiffness matrix, must be, okay, the structure, in the structure stiffness matrix, the value, okay, must be written in order. Must be written in order means from 1 to 6. From 1 to 6. Element global stiffness matrices sama dengan trust dulu juga, mesti kena label near XY, far XY. Yang ni beam near YZ, far YZ. But for structure stiffness matrix, we must label it in order. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Okay, so EI constant. EI constant. So we have to find the value. Okay, the value 1, 1, 1, 2, 1, 3 until 6, 6 from K1 and K2. From K1 and K2. Yang ni simple mathematics. For example, if you want to calculate the value at position 1, 1, So we have to find 1, 1 in K1. We have to find 1, 1 in K2. Total these two, we get 1.777. Okay, one by one. You have to do it one by one. So that's why label is very, very important. Okay, then next 1, 2. Where is 1, 2? So 1, 2, there is no 1, 2 in K1. 1, 2 in K2. We have 1, 2 here. 1, 2. So it is 0.667. And then we continue the same process until we get all values. Okay, until we get all values. And you can also write your answer like this. Means that macam ni je. It must be diagonal like this because the matrix must be symmetry. Must be symmetry. Okay? So continue the process until we get all K. Until we get all K. Okay. So now we move to next step. What is the next step? Because in this beam beam is not like truss. Because truss loading, in truss loading dia semua subjected at nodes in truss. Truss analysis for stiffness using stiffness method. Truss, when we analyze truss, loading is subjected directly at node. So when loading is subjected directly at node, it is called as nodal forces. Nodal forces. But in beam, normally the loading will be UDL, okay, point load, and all this will be subjected on the member, along the member. Okay, so if we look at to this, okay, so for beam, when we want to analyze unknown displacement and unknown reaction, we will apply the stiffness equation KD plus Q naught. Okay, maybe ada beza sikit dengan nota dalam U future, tapi this is the easiest. This is the easiest. We separate between nodal forces Q and Q naught, which is called as equivalent nodal forces. Q naught is called as equivalent nodal forces. So what is equivalent nodal forces? Equivalent nodal forces ni sama macam kita calculate FEM. Sama macam kita calculate FEM, fixed end moment, tapi kat sini kena include sekali not only moment but also the vertical reaction, fixed end reaction lah yang ni. Dia fixed end reaction. So this is equivalent nodal forces. Sinilah. Q naught ni Q naught ni equivalent nodal forces. Equivalent nodal forces, okay, which is similar with fixed end reaction. Fixed end reaction. The same table, the same formula yang you pakai untuk analyze FEM. Moment distribution method. Moment distribution method, you have to calculate FEM. Okay, so yang ni pun sama, moment FEM lah, tapi sebab kita kena consider juga the vertical reaction, reaction at support, so it is called as fixed end reaction, sama. So Q naught ni is for, okay, for members yang macam ni, yang ada loading on top of the member. We have to distribute the loading to the nodes. Because you have to remember, when we analyze structures using stiffness method, we will analyze displacement and forces at nodes only. We will calculate the displacement and reaction at nodes. Sama macam when we analyze, when we model the building in the software, we can get the output at nodes only. Okay. So, bila ada loading like this, UDL on the member, what we need to do, we have to distribute it into nodes. Okay, we have to distribute because member cannot carry load. So, we have to distribute it. We distribute it equivalently. That is why we call it as equivalent nodal forces. Okay, it is Q come from force or loads that is subjected on the member. We have to distribute it equivalently. We have to distribute it equivalently. We use formula given in appendix page 3. Okay, appendix page 3, it is called as fixed end reaction. Okay, but before that, as usual, we label first Q and D. We label first Q and D as usual. Q and D also have six position. So we know the boundary is here. This is the boundary. Not the boundary. This is the separator. Separator between unconstrained and constrained system. Unconstrained and constrained system. So this is D1 and D2. Okay, and this is unknown reaction at the support 3, 4, 5, 6. D1 and D2 is for unknown displacement in unconstrained system. So the remaining, we have to go back to the definition. The physical meaning. What is D1, what is D2, what is D3 until D6. So why D3 until D6 is 0? Because this is displacement at support. Displacement at support representing benda ni. Ini dia 4D yang kosong tu. Okey, 4D yang kosong tu D3 0, D4 0, D5 0, D6 0. Macam mana dia dalam diagram? Okey, macam ni lah. Okey. So D3, D4, D5, D6. D3, D4, D5, D6. So dia akan based on kita punya label lah. So this will be D3 actually. This will be D4. Okay. D4. This one is D5. This one is D6. Okay. So you cannot see you cannot see D punya label tu as number. Tapi you kena tengok what is the definition, the physical meaning. So D1 representing what? D2 representing what? D3 representing vertical. D3 representing vertical displacement at A, which is equal to 0 because it is located at fixed A. Fixed support at A, and A is fixed support. Okay. D4 is rotation. D4 is rotation at A. D4 is rotation at A. D5 is vertical displacement at B. D5 is vertical displacement at B, and it is equal to 0 because of the roller support. Okay, same goes to D6. D6 also 0 because it is displacement at C. And displacement at C, because of the roller support, it is equal to 0. So what is D1 and D2? What is D1 and D2? D1 is D1, D2. Okay, yang ni. D1, D2. So degree of freedom in Z component, in terms of displacement, it is rotation. So D1 means theta at B. D1 means theta at B. D2 means theta at C. So this is what we want to calculate. This will be the first output that we can get from the force displacement equation. Okay. So sama juga kita tengok Q macam tu juga. Q, there are 6 position of Q. There are 6 position of Q. So what is the physical meaning of Q1? What is physical meaning of Q2? Okay. So in terms of forces, in terms of Q, position 1 and position 2, Z component, it is representing moment at position 1, moment at position 2. Okay, 1 and 2, in terms of displacement, it is theta. 1 and 2, in terms of Q, it is moment. Moment at 1, moment at 2. So, refer back to the question. Ada tak moment at B, moment at C? Okay, there is no moment. So, that is why Q1, Q2 equal 0. 0, 0. Because kita belum include Q0. Kita belum include lagi UDL. Okay, into Q. Kita belum include. Because kita akan apply formula ni. Okay, kita separatekan between Q and Q0. Okay, now we want to move to equivalent nodal forces. Equivalent nodal forces. So, equivalent nodal forces will be determined, okay, in order to distribute member loads to the nodes and will be calculated using fixed end reaction formula. Okay, so here I have, okay, just put the two formula that we'll be using in this example. Okay, we have UDL as usual, UDL to WL squared over 12, and we have WL yang ni yang ni we have sini juga fixed end reaction. Fixed end reaction. Okay, same goes to this. Okay, this is fixed end reaction. And for the vertical reaction, this is P over 2 lah. P over 2. And for UDL, it is WL over 2. WL over 2. Okay. And we will establish Q0 in 6 position like this, from 1 to 6. So we will find the value from position number 1 to position number 6. Okay, and we will do this by separating. Okay, kita akan buat ni element by element. Just like we analyze K, we analyze it separately first, then we combine. Just like we calculate K, capital K is K1 plus K2. So yang ni pun based on element dulu, kita calculate element by element, because element 1 is W and element 2 is P, dia punya loading. Okay, so we calculate it separately. We divide into 2 element balik. Okay, so this is the label that we use. Okay, for K1 and for K2. 3451 for element number 1 and we use label 5162 for element number 2. Label dia akan follow sebiji macam label K. Okay, label untuk Q equivalent nodal forces, tapi kita nak calculate for element, one by one element. Okay, so what we need to have is, okay, ini my suggestion lah, my suggestion. Okay, kita draw two diagrams. So, ni yang number 1, number 2 lah. So, this is for element number 1. This is for element number 2. So, for each element, what you need to do is, we have to sketch these two diagrams. Okay, number 1. Okay, it is element number 1, member AB tu. Element number 1, member AB. Okay, and put the degree of freedom like this. 3, 4, 5, 1. Step number 2. Okay, this is the formula. Okay, the formula to calculate fixed end reaction. Fixed end reaction, W is 1, length is 9. Okay, W is 1, length is 9. So, this is formula. This is formula. But maybe you don't have to write the formula. You just need to write the answer directly. Okay, so it is WL over 2 is 4.5. WL is 9 divided by 2, 4.5. So this is 4.5, right? Okay, and WL squared over 12. W is 1 times 9 squared. WL squared over 12. It is 6.75. 6.75. Okay, so this is for element number 1 and element number 2. For element number 2, okay, this is for element number 2, label 5162. Okay, this one label 5162, and then we draw another one. We put the loading, we put the formula, or we put the value after we calculate based on the formula. So it is P divided by L. P divided by L. It is L over 2. It is L over 2. So it is 5. This one is 5. Okay, it is PL over 8. It is PL over 8. P is 10. 10 times 3. PL over 8. It is P. L is 3 over 8. It is 3.75. 3.75. 3.75. Okay. So we will get, where is it? So beam ni, if you understand well about how we calculate equivalent nodal forces, okay, so the rest will be easier. Okay, so now we are going to establish what we call as equivalent element nodal forces. Kita nak gabung jadi equivalent nodal force. Equivalent nodal forces. Q naught, Q capital. Q capital is for the whole, for the structure. Small letter is for element. So now we are calculating equivalent nodal forces for element. For element, label dia label Q small letter. Okay, Q small letter. So here we need to put theta, not theta, not here. Q1 naught. So it is just like this. So we have to combine Q element number 1. We put label naught for equivalent nodal forces plus Q element 2. So I forget to put not here. So it is Q1 not Q2 not. Q1 not Q2 not. So the position of degree of freedom is just like K. So for Q1, the position will be 3451. And for element number 2, the degree of freedom position is 5162. Okay, that's the position. That's the position. Same like K1 and K2. 3451 and 5162. So, what is the next step? Okay, for element number 1, refer back to this diagram. Okay, so compare both diagram. Compare both diagram means that if we want to calculate the value at position number 3, the value at position number 3 yang sama dengan dia, yang sama dengan ni, it is 4.5. Okay, yang sama dengan dia, it is 4.5. This one. Okay, value at position number 4. Value at position number 4. Position number 4 is this. Means that it is moment. Okay. The direction is same direction. The value is 6.75. So it is at position number 4. So it is 6.75. Okay. So next, move to position number 5. Position number 5. Position number 5 is 4.5. So we put 4.5. And position number 1. Position number 1. Okay, position number 1 is moment. Position number 1 is moment. Okay, but the direction is opposite. The direction is opposite. So we have to put negative. Okay, it is very simple, very straightforward. Okay, so same goes to Q2 not. Q2 not, position is 5162. Position is 5162. So compare both diagram. Compare both diagram. We want the value at position number 5. Position number 5, it is 5. Okay, position number 1, it is 3.75. Position number 6, it is 5. Position number 2, opposite direction, it is negative 3.75. Negative 3.75. So now we have Q1 not, Q2 not for element. We have to combine to get the equivalent nodal forces. Okay, equivalent nodal forces. Okay, I forget to put this. Okay, Q1 not and Q2 not. Again, here also same. And actually, you don't have to show this. You don't have to show this. Yang ni je kita nak. Okay, so we want to find the value at position number 1. The value at position number 1, it is 1 and 1. So total that. Okay, total we get negative 3. Negative 3. And then for position number 2, because it must be in order. Sebab yang ni for the structure, for the whole. For the whole must be in order. Number 2. Position number 2. Position number 2. Mana position number 2? Okay. Negative 3.75. In K2 not. Only. Negative 3.75. Okay. Simple lah macam K tadi juga. one by one, dapatlah 6 value. 6 value. Then substitute into equation. It is stiffness equation or force displacement equation. Okay, force displacement equation. It is plus Q naught. So we write it like this. Okay, and then to solve, we have to rearrange back. Okay, before that, in solving unknown displacement D1 and D2 here, D1 and D2 sini, D1 and D2, because displacement at support equals 0, when displacement at support equals 0, so 3, 4, 5, 6, 3, 4, 5, 6, 3, 4, 5, 6. Sebab kali dengan 0 dapat 0. So that is why we just need to consider yang ni je. Whenever we want to solve unknown displacement, okay, without support settlement effect, so what we should do is we just need to consider stiffness equation corresponding to unconstrained degree of freedom system. So we rewrite it back, we get this. Okay, we get this, and then we solve. Dapatlah D1 and D2. D1 and D2. So once dah dapat D1 and D2, then macam biasalah, macam trust, we substitute back into this lah. Okay, we substitute back into this. Okay, kena pakai nilai kat sini which is symmetry dengan ni. Okay, to calculate Q3, Q4, Q5, Q6. It is just matrix multiplication. Okay, value kat sini. Value dekat sini 0.0740. It is 0.2220. Okay, simetri kan. So, complete balik yang ni lah tadi. Okay, yang ni tadi tu. So, yang ni 3 lah. Yang ni 3. Sebab kita dah ni 3 kan. Ni 3, 3. So, ni 3 lah ni. 3, 4, 5, 6. Yang ni 1, 2. This is just matrix multiplication. Matrix multiplication kali dengan D. Kali dengan D. Plus balik dengan Q naught lah. Plus balik dengan Q naught. So, we will get Q3, Q4, Q5, Q6. And this Q3, Q4, Q5, Q6 representing tengok balik the position. Okay, if it is in X, not in X. If it is in Y component, it is vertical reaction. If it is in Z component, it is moment at support lah. Moment at fixed support. Okay. So, dah dapat semua ni. Like this. Okay. Gunalah kaedah apa pun. As long as you dapat this value, it is matrix multiplication only. Simple mathematics. Revise baliklah mathematics kalau tak boleh calculate ni. Okay. Dapatlah Q3, Q4, Q5, Q6. Once dah dapat ni. Okay. Yang ni saya dah transfer all the reaction into diagram. And from this, we can straight away draw the shear force diagram. And after that, we can calculate bending moment diagram, because bending moment diagram, the moment is actually the area of shear force diagram. So, yang ni, video cerita tentang this example, this is not the first time. Last time pun dah cerita juga. Okay, cerita macam mana nak dapat shear force bending moment diagram. Okay. So boleh refer that one also. Okay, this is how we analyze beam using stiffness matrix method from A to Z. From A to Z. Okay. So benda yang sama lah dekat sini. Example number 2. Sama je saya dah buat. Sama juga macam yang atas. Okay, I believe kalau yang atas tadi you understand, you should be able to understand this one as well. Sama. Okay, labeling. Okay, don't forget, this is very, very important. Labeling. Okay, lepas tu combine. Dapat yang ni. For the structure stiffness matrix. Okay, in this case, dia ada kat sini. Okay, that is why masa nak label tu, kena label it correctly. Masa nak label mula-mula tu. So, there are 6 degree of freedom. Pecah into QU and DU. QU is unknown reaction. Tengok pada support. Tengok pada support. So, sini ada, sini we count 2, sini we count 2. So, 4 lah. 4. So, ada 2. Okay, remaining 2. But bila kita draw, kita nak sketch tu, bila kita nak sketch separately tu, kita akan nampak more clearer lah. So, this will be A, B, C, A, B, C. Okay, at fix we have macam ni. Okay, and then at unconstrained, we get macam ni. In total, bila total balik dapat total 6 lah. Dapat total 6. So, label lah. Label 1, 2, 3, 4, 5, 6. So, now kita tahulah. So, kalau dia D at position 1, D in terms of displacement at position 1 means D1. So, D1 ni apa? So, we have to be able to see the physical meaning. D1, what is D1? What is D2? D1 is delta at B. D2 is theta at B. Okay, so the rest is for yang ni unknown lah, yang ni unknown yang kita nak calculate. So then continue dengan unknown reaction at the support. So sama aja dia punya step. Cuma dekat sini dia ada nilai Q. Dia ada nilai Q sebab dekat B ni dia ada nilai ni. Okay, which is subjected directly at nodes. Bila loading tu, dia dekat B ni as node. Dekat B ni as node, when it is subjected directly at nodes, so dia akan ada value lah at position 1 and at position 2. UDL akan masuk dekat Q node. UDL akan masuk dekat Q node. Lepas tu buat macam tadi. Buat macam tadi juga sama. Step tadi tu. Okay, cuma in this case Q2 node ni. Ini node, lupa nak tulis. Okay, dia jadi 0 lah. Because tak ada loading on the beam. Element number 2. Tapi element number 1 ada UDL. So, buat step tadi dapat yang ni. Combine dapat 6 position. Q node at 6 position. Dapat Q node at 6 position. Okay, dapat Q node at 6 position. Semua step sama sebiji macam tadi. Okay. Kalau you faham yang tadi tu, of course you boleh buat yang ni juga. Okay, so dapat yang ni Q node. Yang semua ada node ni, lupa. Q1 node, Q2 node. Okay, combine. Okay, Q is equal to KD plus Q naught. And then we only consider unconstrained system when there is no settlement effect. And then we will get, yang ni unit salah pula ni. Sebab D1 representing, D1 representing vertical displacement, meter. Okay, ni sebab copy paste hari tu. Okay, so continue. Calculate unknown reaction. Calculate unknown reaction. Don't forget, unit dia takkan sama sebab dia ada yang jadi moment, ada yang jadi vertical force, vertical reaction. That's why ada yang kilonewton, ada yang kilonewton meter. Ni pun salah type ni. Salah type. Kilonewton meter moment. And then, continue dengan draw shear force diagram and bending moment diagram. Okay. Macam tu je. Okay. So quite simple It is quite simple, quite straightforward, and I believe kalau you betul-betul nak belajar topik ni, kalau you nak betul-betul nak score topik ni, you memang boleh score. Okay, stiffness method dalam final assessment ada 2 question. 2 question for 50 marks. Stiffness method. Okay. So, kita tengok soalan past years. Okay. So you boleh on microphone if you have question to ask. Stiffness method, beam. Macam tadi je lah. Macam tadi je. Kejap, kita clear dulu yang ni. But this question has support settlement. Support settlement. Okay. So this is the beam. Sama macam tadi juga. Okay. Tapi ada support settlement lah. Support settlement. So still 3 nodes. 3 nodes A, B, C. So there are 6 degree of freedom. This 6 degree of freedom ni. Okay. When we look at this conventionally, they are 1, 2, 3, 4, 5. We only count 4. So yang ni 4 lah. 4. Q, U, and 2, D, U. So this is unconstrained system. This is constrained system. Okay, sama je macam tadi tu. Unconstrained, constrained. Okay, this is A, B, C, A, B, C. So we put 4 in unconstrained, remaining 2 in unconstrained. So label, it's up to you nak label macam mana. Okay, it's up to you nak label macam mana. So let's say yang ni kita label 1, 2. 3, 4, 5, 6. Okay. Okay, 6 ya. 6. So from this, ada position tu kena write. Q lah. Q. 6 position. D. 6 position. Okay. Q dengan D 6 position. Okay. So, macam biasalah sini D1 and D2. D1, D2 still unknown. Lepas tu dia kata dekat B. Point B settle. Point B settle sini. Delta at B settle 0.005. Downward. Okay. So apa label yang kita pakai dekat B? Label yang kita pakai dekat B 4. Okay. 4. So at position 4 nilai dia negative 0.005. Yang lain 0. Okay. So dia akan ikut macam mana kita label. Kalau kita label dekat B tu kita label 3, dia jadi D3 yang negative 0.005. Kalau label kita tu 6 dekat situ, kalau dekat B tu kita label as 6, dia jadi D6 yang negative 0.005. The rest 0. Okay, lepas tu Q we have Q3, Q4, Q5, Q6. 4 unknown reaction. Okay, Q1 and Q2. Q1 is moment, Q2 is moment. Sama juga Q1 dengan Q2 tu, tengok apa yang kita label dekat B. So dekat B, we label as 2. Okay, at position 2, at position B tu, this 30 ni. Okay, this 30 ni. Position dia position 2 dekat B. Position 2 dekat B. Direction dia opposite. Direction opposite jadi negative. Nilai dia dekat position 2. So it is negative 30. At position 1, it is 0. It is 0. So this is the only different. Lepas tu Q0 tu buat macam biasalah. Q0 for Q10 and Q20 macam step tadi juga. So kita akan dapat Q lah. Q, satu lagi is Q0. Q0 ni 66 ada value. 66 ada value. Lepas tu substitute. Okay, lepas tu write in the stiffness equation. Write the stiffness equation. Tapi tengok pada soalan ni Soalan ni kalau dia tak sebut langsung. Kalau ni dia tak sebut pun kata write stiffness equation. Tak ada dalam ni. Yang dia sebut using stiffness method calculate unknown displacement. Okay. So bila you kena bagi in full equation is when dalam soalan dia sebut establish force displacement equation. Establish stiffness equation. Tapi dalam this question, this hanya sebut unknown displacement. Example tadi saya bagi full in detail. Tak ada step yang tertinggal. Okay, tapi kita kena understand that bila kita nak jawab exam, kita tak cukup masa. So, we have to work smart. So, jangan buat benda-benda yang akan buang masa. Okay, so kita nak fokus pada unknown displacement. Unknown displacement occur in unconstrained system. So kita nak yang tu je. Tapi kena include, don't forget, we have to include position number 4 sebab dekat position number 4 tu D4 ada value. Okay, and saya dah buat video pun, explain macam mana kita nak consider unknown displacement. Macam mana kita nak consider unknown displacement, okay, dalam calculation. Untuk calculate unknown displacement itulah. Okay, dah ada video. Saya dah letak kat YouTube dah. Okay, and dah bagi link juga dalam group. Tapi example tu example trust. Ada dalam textbook juga. Okay, so we will produce stiffness equation like this. Q, K, D1, D2, plus lagi satu. Kalau sini 1, 2, sini 4. Yang ni take from full K tu. Kali dengan sini negatif. Sini kali dengan D4. Barulah plus dengan Q. Another Q. Sini plus dengan apa? Sini kita plus dengan Q. Ini Q naught. Yang ni Q. Okay. So this is how we analyze this. So yang ni we solve and we get displacement. Solve this, we get displacement D1, displacement D2. Yang ni. Okay. So this is example question. And okay. Tengok baliklah video yang saya dah explain about how we analyze beam, considering beam pun ada, truss pun ada. Considering support settlement, how we need to include that into calculation. Okay, so soalan ni hanya tanya sampai unknown displacement only. Okay. So actually kalau you tengok malam ni, video ni, you understand very well. Okay, try to understand and betul-betul kalau you faham, you dah boleh pegang 25 marks in final assessment. Macam itulah. Okay, straightforward. It is quite straightforward. Okay, yang ni apa? Yang ni trust. Yang ni pun sama je. Cuma yang ni ada 8 lah. 8 degree of freedom. Sama juga ada settlement. Sama juga ada settlement. It is 8 degree of freedom. So tambahlah K1, K2, K3. And Q naught juga ada Q1 naught, Q2 naught, Q3 naught. Okay, Q1 naught, Q2 naught, and Q3 naught, and only Q3 naught ada value. Q1 naught, Q2 naught tak ada value. Okay, so yang ni dia kata establish structure stiffness matrix. K kena bagi K in full sebab dia tulis kat situ establish structure stiffness matrix. Bagi 8 kali 8. Determine unknown rotation. Unknown rotation memang adalah unknown rotation dekat sini. Sebab ini pin pin sama je macam roller kan. Okay, sini curve. Okay, memang akan ada theta B, theta C, betul lah, theta D. Okay. Determine unknown rotation at occur at B. Okay, yang A dengan B ni yang standard lah. Tapi yang C baru kena include yang ni. Okay, cuma ada tambahan sikit je lah dekat C tu. Tambahan sikit untuk get full mark. Okay. So basically memang saya dah cover all untuk beam analysis. This is how we analyze. Please do exercise. Tengok balik nota. Okay, tengok balik nota. Memang dalam nota dalam U Future. Nota yang dalam U Future tu is not my notes. Okay, itu nota yang saya ambil dari Shah Alam. Dia daripada Cik Rosul. Okay, daripada Cik Rosul. Cik Rosul come from Shah Alam. So, sama je. Tapi ada sikit difference bila nak solve Q note. Sebab dia tak buat pecahan Q note macam ni. Okay, nota tu bukan nota Cik Rosul tapi nota tu daripada Shah Alam. Cik Rosul bawa daripada Shah Alam bila dia pindah sini. Okay. Dan saya upload je nota tu. So, mana-mana pun boleh buat. Tapi kena careful lah. Bila you buat other methods. Bukan other methods. Bila you buat cara lain. Careful dengan sign. Sebab ramai saya tengok yang buat guna teknik lain daripada ni, dia akan silap sign. Kecuali you really understand. Tapi kalau you buat ikut step ni, you tak payah kisah pasal sign. You memang akan dapat the right sign. The value with the right sign. Okay, you tak percaya, you try buat. Okay, kalau you draw diagram nanti, you boleh close loop, means that the answer is correct. Okay. So, dia tak ada salah kat mana-mana pun. Dalam buku kalau you tengok nota-nota buku yang Shah Alam actually dah keluarkan satu buku pasal stiffness method ni, solution dia. Dan sama jugalah macam nota tu. And buku-buku lain pun ada juga. Tapi yang tunjuk contoh macam yang saya tunjuk ni, tak ada. Okay. So, pilihlah yang mana yang you rasa comfortable and make sure jawapan betul lah. Okay. Okay, so I think that's all good for beam analysis. Frame pun sama je macam beam. Actually beam bila you dah faham truss, bila you dah faham truss, bila you dah faham beam, frame ni combination only, dia gabung. So gabungan dia kat mana? Gabungan dia kalau dekat frame ada CX, CY. So frame ada coordinate, frame ada arrow. Itu yang dia ambil daripada truss. Lepas tu dekat frame akan ada UDL, dia akan ada point load macam kita analyse beam. Yang tu dia ambil daripada beam. So dia gabungkan semua tu jadi frame analysis. Cuma formula pada frame ni nampak macam complicated sebab dia 6 by 6. 6 by 6 sebab 3 nodes, 3 at near nodes, 3 at far nodes, jadi 6 by 6. So, nampak complicated. Tapi sebenarnya sama je. Value dalam matrix yang 6x6 tu hanya ada 4 value yang berulang. Okay. Lepas tu step-step dia sama macam step beam. Sebiji sama macam step beam. Okay, tak ada different langsung. So, sebenarnya kalau you faham truss, you faham beam, combine. Okay, combine yang tu, you akan boleh buat frame. Okay, you akan boleh buat frame. So, esok tak ada sebab cuti. Okay, tapi saya akan, insyaAllah esok saya akan assign. Tak payah assign lah, you tengok lah dalam ni berlambak ada. Okay, saya dah letak past year's exam papers. You boleh tengok juga past year's exam papers ECS 556 and also ECS 468. Okay, boleh search ECS 468, ECS 556, CES 521, CES 421. Okay, untuk tengok past year's exam papers. Okay, kalau you buat latihan, you boleh letak dekat OneNote and you boleh minta saya untuk check. Okay, so stiffness method topik paling senang nak score full mark. As I mentioned tadi, final assessment ada 60 ada 50 markah come from stiffness method. Okay, so assignment yang baki 10% tu, kita kan dah rombak hari tu, assignment baki 10% tu, saya akan bagi soalan stiffness method lah. Stiffness method. Okay, assignment. So assignment saya nak bagi frame lah. Assignment saya nak bagi frame. Okay, nota frame nanti saya masukkan. Saya rasa textbook pun ada kat sini. Okay, frame ni. Okay, I will give you one frame question, covers 10% assignment. Okay, 10% assignment sebab kita dah go back to original syllabus lah, bukan syllabus, original assessment. Okay, before pandemic, asal balik. Okay, kita kena go back to 30% test, 10% assignment, and 60% final exam. Okay, so I think that's all from me. Okay, boleh buat exercise and saya boleh check for you. Okay, nanti insyaAllah dalam minggu ni saya akan bagi frame question for test. Saya tak cover lagi, saya tak akan buat in detail lagi video untuk, saya tak akan buat kelas untuk frame sebab dah ada video. Dan dia sebiji gabungan truss and beam. Kalau you faham truss, you faham beam, you boleh buat. Okay, so that's all from me. So thank you. Don't forget to tick your attendance in the near future. So thank you for joining. We meet again insyaAllah next week. Next week hari apa? Next week hari Rabu lah insyaAllah. Okay, so thank you.